So now I want to ask my colleague to help you with some real live use cases along with these instances. So what we are going to do now, we are going to talk about the use cases for Amazon EC2. And Crystal is going to help us today. She has created, she will be walking us through a POC and will help us to understand how that particular works. So Crystal, if you are up, please share your screen. I'll add you to the stream and we can get started from there. Yeah, move
Okay,
forward.
I'm conscious that my colleagues also have things to share, so I'll try to be brief on that one. But basically, what I want to show with you, to share with you, I want to ask you to put yourself in the role of an architect, and we're going to use a use case, very easy use case, and we're going to consider some very important factors for a solutions architect. These are things that we have to keep in mind when we design solutions for our customers. Okay. So the use case is pretty simple. We are working with an architect in a school, and what they want to do is to host their one of the catering service website on AWS, so that students can actually they can check the balance to know how many meals they can buy for the rest of the month, and they can also top up their card. So something super easy, and we're going to go on a journey of a solution architect to kind of build something super simple for that. Okay. All right. So we've got the AWS cloud. We've got one availability zone. We have our students there. They want to top up. So you've just heard about the EC2 instances. That's a great place to actually run our websites. Now, basically, what we could do here is that we can just provide direct access to the website for the students. But there's a lot of things that we can do here to actually improve our architecture. Now, I'm adding a database here. We haven't covered databases for now, but basically, when our students are basically accessing the website, they are going to store some data. There will be data stored about how much left they have on their cards, how much money, their name, their last name, their student number, the card number. We're going to put all of that data in a database. Okay, so that's just the reason I put a database there, but it's not the focus for today. Okay, so first thing we have to think of when we design architecture is security. If we provide direct access to this for the students to the website, if we want to think about how can we make this access as secure as possible, so that's students can connect safely and nobody can see what they're doing. They're putting their card details. It has to be hidden. So one thing that we can think of to actually improve the security of this design is to add encryption in transit. So see, when you go on the internet, you see this HTTPS, right? And then you put your website. The S is for secure. So we're going to use some mechanism within Amazon Web Services to make sure that this traffic is encrypted. So when the students actually go and top up their card, nobody can see what they're doing. This traffic is completely encrypted. Okay, so that's the first layer of security we can think of. Now, all of the students, they can put their card numbers and the student card numbers and basically their access to the environments. Wouldn't it be nice if they had actually a way to log in so that they have their dedicated accounts there? So another thing that we can think of here is to add an authentication layer that is going to allow our students to put their credentials, to log in, and to have access to their dedicated profile, okay, where they can do all sort of stuff. So these are two quick ways that we can think of to improve the security of this design, and we have already made one improvement. Okay, super easy. Now, let's move on. The next thing is reliability. When we design, we have to think about worst case scenarios. What happens if the servers crash? Unfortunately, this is what happened to us. And sadly, we only had one instance. So that was a single point of failure here. That wasn't good design. So what we could have done, actually, is to have deployed another EC2 instance where that also has access to our database, so it can retrieve the same data, that was actually stored from this initial server, so that if this instance is no longer available, then the second one is going to serve our website. It's super important for the IT person in the school that they can provide to the student something that is highly available. Now, the question you might ask me is, if there are two servers, how do the students know if they should access this server or this server? Actually, they don't know, and they don't care. So we need to find a way, we need to find a mechanism to actually have something that is going to balance the request towards, the servers that is online and not the server that is not online. So what we're going to use here is actually a load balancer. Now, I'm not diving deep into the AWS services that do that. I'm just showing you some concepts that work with your EC2 instances. So this load balancer here, its job is going to take all of the requests from the students, and then it's going to direct the traffic to the available server. Okay. Now, once our other server comes back online because we've connected, we've fixed the issues, and so on, maybe what we can decide is actually to split 50-50 traffic between our two servers, so that we actually spread the loads between our two servers. So one is not too overloaded compared to the other one. That's one of the ways we can design that. There are other ways, but I'm just showing you what is possible here. Okay, so now we have a design that is secure. We have a design that is highly available. So our students are pretty happy. But because this is this website here is actually to top up the lunch card. So what happens is that at the end of the month, all of the students, they connect all at the same time, and we are having some performance issues. They are complaining because it takes 5 seconds for the page to appear. Sometimes they get some timeouts. Sometimes it just doesn't go through. So another thing that we have to think of as architect is performances, also during peak time. So end of the month is a peak time. Everybody connects at the same time. Performance are impacted. How do we fix that? One way we can do that, we can actually deploy many servers, right? That's good. It's going to cost a bit of money, but if we only need to have more instances at the end of the month, we're going to be paying for these extra resources, for an entire month where we're not going to use them. We're going to use them maybe for, I don't know, 7 days of the month. It's not good best practice here from a cost perspective. What we can do instead is to think of auto-scaling capabilities, where we are going to tell our EC2 instances one condition. You are going to add +1 server when our servers are reaching 70% CPU utilization. So we're going to give the condition to add extra resources. So now what's going to happen is that at the end of the month, when all the students are connecting at the same time and our servers are reaching 70% CPU utilization, another server is going to get deployed, okay? And same on the other side. All right. So now we have a design that is secure, we have a design that is highly available, and we have also taken performance into account. Now, if we want to push this a little bit further, we can use 2 availability zones, for example. There's a lot of things that we can do, but I just wanted to share the 3 aspects that we always consider as architect: security, reliability, performance. There's one more that I could quickly share before I transition to my colleague. It's operations. We don't want to be manually changing stuff all the time. One of the ways that we can reduce our time managing the infrastructure is to use AWS managed services, for example, or we can use serverless services, or we can use infrastructure as code. These are basically mechanisms that help us to spend less time doing manual improvement on the architecture, because the more you scale, the less you want to be manual on your architectures. If you are too manual, you can get into troubles for actually making mistakes. So you really want to improve your operations or as your design skills.